Okay, now in the second page, I have an example, a simple example. Now we need to compare between the work and the kinetic energy. And we will see also what is the kinetic energy again when we deal with the elastic kinetic energy. Okay, in the second page example, computer lift from one. Yes, we need to lift mass 3 kilograms from, if this is 0, we need to lift it from y equal to 5 to y equal to 10. With constant velocity, we don't need any acceleration. That means the force we need to apply is equal to the weight, which is mg. Okay, what is the work? The work is equal to F dot delta y. Delta y, I use now the dot product as you see. Delta y is upward. The applied force will be equal to the negative mg, just as the second case. You can use F applied is negative mg, delta y as 10 minus 5, and cosine 0. Or you can use, as I solved it in the example, it is equal to mg, the applied force, 10 minus 5, cosine 180. So this is equal to M is given 3, G is almost 10 or 9.8. 10 minus 5 is 5. Cosine 180 is negative 1. So my work will be negative 147 joules. Because I lift the objects from 5 to 10 by a force equal to the gravity force. Now I'm asking not about my force work. I am asking about the work done by gravity. The work done by gravity, it is Wg. It is negative. It is in the opposite side. The gravity is downward, and the work done and the motion done in the opposite direction of that force. Because of that, it will be negative. Now, if I need to ask about the change in potential energy. I can take, this is 5 meters, this is 10 meters. The potential energy U at 10 or U finally is equal to mg multiplied by y, which is 10. And U initially is equal to mg multiplied by 5, which is y initial. And this is y finally. I can solve two equations. But simply, we found now that the work done by gravity is equal to the negative potential energy done by that force. So it will be equal to the negative 147 joules, which is positive 147 joules. This is the change in potential energy. Now, in this case, if I ask you, if I let this object to fall down from 5 meters, and I have a glass here, which is a strong glass, okay? From 5 meters and fall to that glass, it will break it or smash something to big pieces. But if I throw it from 10 meters, the effect will be bigger or smaller. It will be bigger, will smash it, okay? Smashing the cup to these pieces, then these pieces need more energy because it's smaller. We need more energy, right? These pieces appeared after falling from 10 meters. These pieces appeared after falling from 5 meters. Because of that, the object at 10 meters contains larger energy. Why? Because of its position. The word because of its position or because of its situation give us the name potential energy. It is a potential energy because of its position here. It's another potential energy because of its position here. Okay? And if the object is move again from 10 to 5, it will give us the same energy, which is 147. Because when we lift it from here to here, we give it 147. If he move from here to here, he will give us 147. The nature is fair. The energy is conserved. If we give energy to a system, and the system needs to give that energy again, it will give the same energy. This thing give us a postulate or something like that, which means that the energy is conserved.